a third method, another method to solve a system. Okay, so far, tell me the couple ways that we could solve a system like this. Like we know probably 3 or 4 at this point. Tell me one. Substitution, definitely. What else? Elimination. Levi, you going to give us one? Sorry. Tell me a matrix method that we know. There's 2 matrix methods that we know. Yeah, and so that's that RREF that we're trying to get in that reduced form. And there's one more. There's somebody's rule. I think we saw it in 10.3. He's got the meme on the side over there. Kramer's rule with the determinant. So we have 4 methods really right now, but this is actually going to then be a 5th. So it's related to matrix multiplication, which is why it comes up. So here's what it's going to look like. And so I only have one example here. There is an additional homework assignment that says 10.4 day 2. It only has like 5 questions in it. Let's see, I think there's only 2 of these. There's a question like we did yesterday with the connections between topics. But so the first thing here is we're just going to write the coefficients. So it's a little different than that augmented matrix. Remember, that's the augmented, the RREF, where we put the equal sign there. We're just going to put the coefficients. And then we're going to multiply that by this matrix X, Y. And we're going to say that that equals our matrix 1, 21. Sometimes this will be called like a matrix equation. It might say, sometimes it'll say like use algebra to solve, but this is what it's talking about. Now first, I just want to recognize that this is the same thing that we've been doing. So if I would multiply these 2 matrices together, what size would that answer be? Can you tell me? When I multiply those together, ignore all of this. If I just gave you this and said multiply, what size would the new matrix be? 2 by 1 is right, so it's 2 by 2. This is 2 by 1, so 2 by 1. So 2 rows, 1 column. So this row, what would I write? So let's think about the multiplication here. You just did one of these, or should have been thinking about it. So row 1, column 1. What would I write? 2x and 3y. What operation there, Levi? Yes. Okay. And then the bottom one would be like it, but it'd be 3x minus 2y. Now, this is not how we're going to solve it. So I don't know if you don't have to write this part down, Olivia. It looks like you're writing it, but just, oh, okay, that's fine. I just didn't want you to take a step here you don't need. But if you look at this, do you remember the homework question? It came up not too long ago. It's one actually you'd asked me about on Wednesday. Like notice that all of this is in that row 1, column 1. And if these 2 matrices are equal, shouldn't all of that be the same as 1? Do you notice that that's what the first equation says? 2x plus 3y equals 1. The bottom equation, so that would have to equal 21. That's what it says. So the point I'm really trying to make is that when I write this equation with matrices, I really have just rewritten the original system. Okay? Now, we have talked about adding matrices and subtracting matrices and multiplying matrices, and that's it. Like, we actually don't have a definition to divide. But if you look at this, isn't that what we would do? Like if we think algebra, right? If I saw this and said solve for x, wouldn't we think divide by 3, trying to get my solution? And I'm looking at this as like, I want that red portion by itself. Well, instead of thinking of division, like there's a connection here would be this, like multiply by 1/3, right? We could think of it that way. Now, what is the relationship between 3 and 1/3? How would you say that? How are they related to one another? Yes, there's an inverse notion there that you might have talked about or should have talked about before. And because when I multiply them, I get the number 1. Now, I want to do something like that for matrices. So take your calculator, and I'm going to call this first one here matrix A. And I'd like you to put matrix A into your calculator. Okay? And we're going to use our calculator to find the inverse of that matrix. So I can multiply to really get that solution for x and y here. So first type that in, and then I'll tell you how to get the inverse. You ready? All right, so on just your home screen where you do the calculations, I want you to, like if you're going to multiply two matrices, I want you to type in A. So go to the matrix, names, choose A. And then what I want you to do is hit the minus or the x to the -1 key on your calculator. It'll be in a different spot. Well, yours are probably both in the same spot. But now, and what you're doing is that when you hit enter, now you actually might see some decimals right now. True? So I want you to hit math, convert it to a fraction. So math, enter, and it should tell you the inverse of a matrix. So Olivia, what'd you get row 1? Okay. Levi, agree? And row 2, Levi? Like that? Okay. So I'd like to get rid of this, but it's a little bit different in matrices. But I'm going to write this out, and then I want you to put this into your calculator. So I'm going to put A inverse on the left side here. Now that's important because do you remember, like, we can't switch the order of multiplication and expect the same thing to happen. So I'm going to left multiply by the inverse. So we're going to write that out. And so here's then what I'm saying. So in symbols, this is what I'm doing. I'm going to say A inverse. I have this matrix A. Maybe I'll call this red one here matrix X. And this is maybe B. Now, the same kind of rules of algebra should apply. Like, I shouldn't just be able to put this on the left side of an equation and think I didn't change something. So if I'm going to multiply one side by something, we'd think in algebra we got to do it to the other side as well. But we need to do it in the same order because matrices, it matters. So I need to actually A inverse here as well. So this is what I mean by left multiply. We have put A inverse on the left side of both of those, both sides. Okay. Now, if you take your calculator and actually just type in A to the -1, the same thing you typed in a second ago, multiply that by matrix A, and I want you to do that. I want you to look at what happens. A lot of times students will say the answer is 1. It's not quite. There's something different about it because it's a matrix. What do you notice, Levi? What do you get? Yes. Do you notice that that's kind of that part that we were after, like when we had that augmented matrix, right? It was that left side of it. This has a name. This is called the identity matrix. the identity matrix. So do both of your calculators have this as an answer right now? So what I want you to do is this, hit second answer, okay? And it should just, your screen should just say answer, right? Yes? And I want you to multiply it by, so just say multiply by, and then type matrix A again. Do you recognize that answer? What is it? Yes, it's actually this same matrix A. So in a lot of ways, this identity matrix is like the number 1 for matrices, though. Okay? So if I multiply by the identity matrix, nothing changes. Now, you can probably guess why. Like if I would put something like, I have some random 4 numbers like this, I can actually multiply it on either side. Look at what happens when we think about multiply. Row, column. What's that answer? You can do it. A times 1 plus. So what's the answer? A times 1, or just A. What about this one? This one's got to be 0. 0 plus something, though. Right? It's going to be A times 0 plus, so what is it? Row 1, column 2. It's B. What's that one? C. Do you see we get the same answer back that we started with? So that's what I mean. It's kind of like a 1 for matrices. It's not going to change the answer. So that means if I'm thinking about this, I want to finish this problem now. So I'm going to go back. I'm just going to zoom out maybe a bit. So if we're going to multiply both sides by A inverse, what we end up with is 1, 0, 0, 1 times this xy equals this A inverse times B. Well, we haven't done this calculation yet, right? So if you take your calculators, go ahead and put matrix B back in, and then calculate A inverse times B. I can see it should be a 2 by 1, right? It's a 2 by 2 times a 2 by 1. So it should be a 2 by 1. What'd you get? 5, negative 3. Now this side, all of that last conversation we were just talking about is like this identity matrix here is going to behave like the number 1, which means the left side just becomes xy. Do you see the answer now? If these two matrices are equal, it goes back to that thought that I was talking about a second ago that, okay, so x must be the number 5 and y must be the number negative 3. You want to ask about that? You can look at one more, I think. Either of you have questions? Okay, let's do a bigger one. So for the most part, we're going to use our calculator again for these questions because we're going to use it to find the inverse. So I do want you to first write, you should have something here that is a 3 by 3 times, and in this case, this is that X matrix, except it's going to be an X, Y, and Z. And then over here, we should have our solution. So this is going to be broken up. Do you notice it's kind of, again, like the augmented in some way, like the blue plus this ends up being that augmented matrix for the REF, so it's a lot like it. So once you do that, you should find the inverse of one of these. Which one? A or B? Will we need the inverse for? It's going to be A. And then if I multiply on the left over here, be sure you multiply on the left over here. If you put on the wrong side, like, you won't even be able to do it. It just won't make sense. So I'm going to pause it, and you try it. So here is one of the takeaways, is that sometimes you cannot find this, which means you can't use this method. It's kind of like Cramer's rule, that sometimes it's broken, it just doesn't work. So what it means is we can't find the inverse, we can't go backwards. Like your calculator says something like air singular matrix. Now that doesn't mean that there isn't a solution, it just means that you can't use this method. Okay, so I'm going to change it here. So what if we change, I'm going to change a couple of values here. So open up your matrix A, we're just going to edit it. So I'm going to make this a plus. I'm going to take away that 31. Does that fix it? I thought that fixed it. Again, you can convert those to decimals, like when you see that decimal, but think about the piece that you care the most about is not really what A inverse is, right? We want to use that to get the answer, which should be sitting over here now. So with those changes, you should be able to get something. This is going to be some decimals over here too. So your final answer, XYZ equals Olivia, did you get something? Did it do fractions? Yeah, I was looking for fractions. No, they definitely are fractions here. Levi, do you get the same thing? So again, it's just another method to solve systems. Again, it breaks, which is what happened there initially, but it's this left multiply of this inverse. This answer is like the one for matrices, giving us the solution. So that's really the end of 10.4. Like I said, the homework's easy. You have it. So have a good long weekend. See ya.